since we jumped into the 8th grade curriculum here in Unit 3, there's going to be some problems that they're going to assume that you have prior knowledge to that we're going to work through as we go. Okay, so if there's ever anything that gets you stuck, just try it and we'll discuss it the next day. And there's one of those here coming up. So would you read the first problem for me, Jonas?
Priya jogs at a constant speed. The relationship between her distance and time is shown on the graph. Diego bikes at a constant speed twice as fast as Priya. Sketch a graph showing the relationship between Diego's distance and time.
All right, do we need to draw our own graph for this one?
No.
No, you can put it right on this one. All right. If you have your own graph paper, that's fine as well, but there should be room here for us to do more than one line. So we mentioned yesterday how fast Priya was going. How fast is Priya going here? 5 miles in 1 hour, right? So if we would plot that point, it'd be 1.5. Any other points that we can be sure of here? This one certainly looks like it's on a point. What would the coordinate of that point be?
3 and 0.6.
0.6. Remember, it's left and right first. And maybe that's enough information. We know it goes through the origin there. 0, 0. So what do we know about Diego? Twice as fast. Twice as fast. So instead of going 3 miles in 0.6 hours, how long would it take him? In 0.6 hours, how far would he go? Let's use the same time. He'd go twice as far. So at 0.6, he would go 6 miles. Let's pick another one here. This would be 0.42. So in 0.4 hours, Diego would go 4. And that should be enough information. We have 3 points if you include the origin. Some kind of a straight edge side of your book to connect the dots. And then I'm going to label that was Diego, this was Priya. Okay, how fast was Diego going?
10 miles.
10 miles an hour. And you could plot 110. That would just be off of our graph there. Questions on that one? All right, question number 2. A blueberry farm. Sketch a graph. The relationship between the cost and pounds of blueberries. All right, so we're going to go pounds and cost. We know that 6 pounds cost $16.50. You could put that dot on there right now. Okay, this would be 6 pounds, $16.50. Somewhere in that vicinity. Could label it. Anybody have another point? We did mention we'd like 3 points on there. Kinley.
I have 0, 0.
0, 0.
Yeah.
0 pounds, it costs $0. Not wrong. Jared.
I had 82.5.
How many pounds?
30 pounds.
So you took it times 5?
Yeah.
And then you got what?
82.5 pounds.
82.5,
$9.
$82.50. Okay, so 30 pounds, just shy of 84. Should label it. Out of curiosity, anybody figure out what 1 pound costs?
Yeah.
No.
2.75.
2.75, so $2.75 a pound. We do have 3 dots here. Find out how good you did with how well they line up. Does say sketch. Only thing they're missing there is a title. I should probably put a title on there. Cost of blueberries. This one you might have had some trouble with. This would have been a review from Unit 2, if we would have covered it. Did anybody sketch it?
I did.
Did you come up with any that wouldn't be on there?
Yeah.
Which one?
D.
Okay. Colin? A? C? Got a lot of different answers. All right, we're going to talk about this more on the next problem, but the only one that doesn't work is C.
That's why I was so confused.
All right, next problem.
I got, yeah, this one I just put down numbers and hoped it worked.
All right, so I'm going to give you
It did.
I put down 2 because I like that number.
a couple of equations here that I want you to be sure to write down. Stars. These will be used throughout here, Unit 3. Again, this is assuming you knew some things in Unit 2, which we didn't cover, so the answer is going to be a little different. But here's what I want you to write down. I want you to write down slope equals rise over run. Okay, what that means is every line is given a slope. That means how steep it is, basically, if you think of a ski slope. Okay, there's different steepness of a ski slope. Anybody that's been skiing. Roads are the same way. If they had too big of a slope on a road, you might not be able to make it up in the winter, for instance. Okay, rise over run. What that means is how far up and down it goes over how far left and right it goes. So rise means up and down, run means left and right. Okay, so if you look at this problem, it shows you 2 different triangles, and what that's trying to show you is the triangles are going to have the same rise and run because the slope of the line is going to be the same. The slope isn't steeper here than it is here. Okay, one line has one slope, no matter where you analyze it at. Okay, so just looking at this triangle, if you're looking at points A and B, how far up do you have to go? And how far right do you have to go to get to the other point? Remember, it's rise first. So they kind of show you here how far up you go, right? They show you right here. 3. So that would be our rise, and our run would be 4. That would be our slope. Slope is usually abbreviated with the letter M. S is used a lot in other things. So anytime you see the letter M, that's referring to slope. And you'll see different forms here as we progress through, forms of equations as we progress through Unit 3. Okay, so this would have a slope of 3/4. One other thing to remember about slope, if you imagine a car driving from left to right on your paper, if it ever goes uphill, like this one, this car would go uphill, your slope will be positive. If you'd ever run into a line that's going downhill, what do you think your slope would be? Negative, so keep that in mind as well. Car driving uphill will be positive, car driving downhill will be negative. Okay? One other thing I want to make note of, and again, you wouldn't have this equation, so I want you to write it down. Just write down that equation for me. Okay, and what that means, if we subtract the y coordinates and we subtract the x coordinates, it'll save us some time from having to graph every point and draw out these triangles. Okay, so I can get any 2 points, and we're going to practice one right now before we move on to the warm-up, just so you can see it. So let's pick a point, let's say 8, 4, and
4, 8.
6, 2. Okay, again, we could plot the points and count, draw the triangles. We could do 4, 8, 2, Jared. Now, which ones are the y coordinates? The second numbers, right? Now, it doesn't matter which one you consider y2, but you just have to go in the same order. For instance, if I do 2 minus 4, that means when I do the x's, I gotta do 6 minus 8. I gotta go the same order. Okay? I always try to make the first one positive, but you don't have to. I could go 4 minus 2, and then I'm gonna go 6 or 8 minus 6. Does that make sense? You have to go the same order. Okay, so which one do you want to subtract first? Again, we're looking at the y's. 4 minus 2. So I'm going to consider this y2, this y1. So I'm going to do 4 minus 2 over, which one is x2 then? That means this would have to be x2, this would be x1. 8 minus 6. So 4 minus 2?
2.
8 minus 6?
2.
That means my slope is
1.
1 would be my slope. So just kind of an idea what that would look like. That means for every 1 you go up, you go 1 to the right. So if we started right here, up 1, right 1, up 1, right 1. Here's what a slope of 1 would look like. Okay, so again, just some formulas to know. And again, you might see those here as we go, things you might not have heard yet, and then we'll just cover it as we go through. Okay, just make note of those two equations. Questions on that? And again, that is slope. We'll get through more of that as we go through Unit 3.